Have you ever created an object in Java and then your whole program just crashes, all because it was missing something critical like a username or an ID? Yeah, it's a super common, super frustrating problem. And it all comes down to how Java creates objects by default. In this explainer, we're going to tackle that exact problem head-on with a simple but really powerful tool, the Java Constructor.
So here's our game plan. First, we'll look at the root of the problem, these empty objects, and why they can be so sneaky and cause bugs. Then, we'll introduce the constructor as our hero, our solution, and I'll walk you through the simple rules for creating one. Of course, we'll dive into some real code examples to see the before and after. And finally, we'll wrap up with why getting a handle on constructors is just absolutely crucial for writing solid, professional Java code.
All right, let's get right to it and start at the very beginning. What is actually happening under the hood when you tell Java, hey, create a new object for me, but you don't give it any other instructions? Let's find out.
So picture this. You've just created a new object in your code, let's say a human object. What's it like in that first moment of existence? Does it have a name, an age, or is it kind of just an empty shell waiting for you to tell it what it is?
Well, Java doesn't like to leave things totally blank, so it gives them default values. For any number, like our age variable, that default is 0. And for any object, like a string, the default is this special value called null. Now, null is tricky. It doesn't just mean empty, it means that variable points to absolutely nothing. So our shiny new human object is created, but with an age of 0 and a name that's pointing nowhere.
So why is this such a big deal? Well, imagine your code tries to do something with that age. A value of 0 is probably going to give you a wrong answer. But even worse is that null name. If you try to do anything with it, like just print it to the screen, your program will immediately crash. You'll get one of the most famous errors in all of Java, the Null Pointer Exception. This is exactly why we need a better way to make sure our objects are valid from the get-go.
So how do we fix this? How do we make sure our objects are born complete with real valid data? The answer, my friends, is the constructor. It's a special little method that gets called automatically every single time you create a new object, and it's the perfect place to set everything up correctly.
You can think of a constructor as the official set of instructions for building an object. You know, like how a car on an assembly line gets its engine, its wheels, and its paint job in a specific order. The constructor does that for our objects. It's the mandatory setup phase that ensures everything is in its right place.
For our human object, the constructor is basically its birth certificate. It's the moment it's given a name and an age. By using a constructor, we can guarantee that every single human object that ever exists in our program starts its life as a valid, complete thing, totally ready to be used.
Okay, this all sounds pretty useful, right? So how do we actually make one? Well, it's actually super simple. There are just 2 rules you have to follow, and they are non-negotiable. Rule number 1, the constructor's name has to be exactly the same as the class name. So for our human class, the constructor has to be called human. Simple enough. And rule number 2, a constructor has no return type. Not even void. You just leave it out completely. Because its job isn't to send a value back. Its job is to set up the object itself.
And this little comparison shows the difference perfectly. See, a regular method has a return type. Here it's void, and you can name it whatever you want, like setAge. But the constructor on the right, its name has to be human, just like the class. And notice, there's nothing between public and human, no return type at all. It's a small detail, but it's a critical one.
All right, enough theory. Let's see this thing in action. We're going to add a constructor to our human class to give it a name and an age, and you're going to see just how dramatically it changes things when we create our objects.
First up, just to prove that constructors are called automatically, we're going to create 2 separate human objects. Look closely at the code. We are not calling the constructor ourselves, right? We're just using the new keyword twice to ask for 2 new objects.
And bam! Look at the output. The message in constructor is printed twice. This proves, without a doubt, that our constructor code ran automatically once for each object we created. This is such a powerful feature because it guarantees that every single object gets properly initialized before you can ever use it. No exceptions.
So let's quickly remind ourselves what it looked like before. When we didn't have a constructor, creating a human object gave us that useless null name and a meaningless age of 0. Not exactly helpful, is it?
But now with a constructor, what a difference. We can give our new human object a real name and a real age right from the moment it's born. And just like that,
we can be 100% confident that every human object in our program is valid and ready to go from the very start. No more nulls, no more zeros, problem solved.
So why do we care so much about constructors? Is it really just about setting a few values? No, not at all. Constructors are a fundamental pillar of object-oriented programming. They are absolutely essential for writing code that is robust, reliable, and professional.
Think about it this way. If you're building an online store, when a customer creates a new order, you need to be sure that order has a customer ID and a list of items, right? By putting all that setup logic inside the order constructor, you can literally make it impossible for an invalid order to even exist in your system. This enforces the integrity of your data and prevents a whole category of bugs right from the source.
Okay, let's bring it all home. If there's one thing you remember about Java constructors, let it be this. They are your #1 tool for creating objects that are valid and usable from the very second they're created. They are your first line of defense against bad data.
So, quick recap. A constructor is a special chunk of code that initializes a new object. Remember the big rules. Its name is the exact same as the class. It has no return type, and it gets called automatically with the new keyword. You master those points, and you've got the core of constructors down.
But this brings up a really good question. What if you need to create objects in different ways? Like maybe you want to create one human object where you know the name and the age, but for another one you only know the name. Can you do that? Can a class have more than one constructor? Well, yes, it can. And that's a concept called constructor overloading, which is exactly what we're going to talk about in our next explainer.